Starting from this section, we will finally begin to prove the prime number theorem with the help of the Selberg's asymptotic formula. Now we have proved Selberg's asymptotic formula, and we want to use it to prove the prime number theorem. Here is our plan. Recall from theorem 420, which says pi of x, the number of primes less than or equal to x, is similar to theta of x divided by log of x, similar to psi of x divided by log of x. Now, in order to prove the prime number theorem, namely pi of x is similar to x divided by log of x, it suffices to show that psi of x is similar to x. Or, more formally, by the definition of this symbol, this means the limit of psi of x divided by x as x goes to infinity is equal to 1. Now we define a function v of x as psi of e to the x divided by e to the x minus 1. And now it suffices to show the limit of v of x as x goes to infinity is equal to 0. Or let alpha be equal to the lim sup of v of x as x goes to infinity. It suffices to show that alpha is equal to 0. And now you may ask, what role of the Selberg's asymptotic formula will play here? The role of the Selberg's asymptotic formula here is that it will provide some integral inequalities for us. And now let me explain. First, Selberg's asymptotic formula implies the following integral inequality, that the absolute value of v of x times x squared is less than or equal to this double integral plus big O of x. And we will use this integral inequality to show that alpha, which is the lim sup of v of x, is less than or equal to the lim sup of this average, which later we'll denote by beta. And second, we'll prove by contradiction by assuming that alpha is bigger than 0. Suppose alpha is bigger than 0, and we will find a contradiction that shows alpha is bigger than beta. And the way to achieve this is another clever application of Selberg's asymptotic formula. We'll show that Selberg's asymptotic formula will give us that the average is less than alpha prime plus little o of 1 with sum alpha prime less than alpha. And taking lim sup in this inequality will give us beta less than or equal to alpha prime, which is less than alpha, which is a contradiction. And the source of this contradiction is that alpha is bigger than 0. So this contradiction will force alpha equal to 0, and thus finish the proof of the prime number theorem.